Okay, Newman motor's up and running. Speed test, about 400-500 RPM. So we're going to juice up the power a bit. In fact, we're going to juice it up a lot. So ignore the shaking, it's probably not that dangerous. That is 2600 RPM. We're going to look at the input power, almost 40 milliamps at 550 volts. And 2600 RPM. So now I'm going to drop the duty cycle down and we're going to have a look at the change in efficiency. Okay, as you can see, I've dropped the duty cycle down by adjusting the magnets. I've taken it down from 85% down to 50%. So 50% duty cycle. I won't run a speed test yet. We'll go and dial up the power. So, speed test. The RPM is noticeably down, and so is the power. And you get some slightly different resonance vibration effects. So down to about 14 milliamps, 660 volts, and 2100 RPM. I'll work out what's next and I'll show you. Okay, I've made another few adjustments to the duty cycle. Duty cycle's now down to approximately 30%. Consequently, the RPM has dropped as well. We're down to about 1900 RPM. And the current is about 11-12 milliamps at 720 volts. So I should mention these results are all skewed a bit because they should be a little better. I'm running them through a 100 ohm resistor for the purposes of looking at these scope shots, which I will proceed to explain shortly. They look familiar, don't they? Well, the next motor is going to have about 2000 ohms of resistance on the coil. Maybe a little over. This one has only 600 ohms in total. And if you look at my H bridge, I'm running the machine through 80 ohm resistors in case something goes wrong. And if we were to get a dead short across the motor while it was running, it would just bang, it would just lock tight in the middle of the rotation. And previously that's been enough to damage rotors before. It just comes to a grinding halt immediately, bang, and the whole thing almost explodes. At least it dislodges the magnets from the shaft in a bad way. And here's another way I'm throwing away power. I've not just got the 80 ohm resistors, I'm also measuring 100 ohms. So I've got an extra couple of 100 ohms, and never mind the extra losses and unnecessary diodes and whatnot, through a set of 600 ohm coils. So this is not really a good case study for an efficient motor, but it's pretty good to learn with. So I've reduced the duty cycle down to where I happen to like it, which is about 60%. And get it firing back up again. And the purpose of this video was to build on some previous scope shots I'd shown you previously, and I'll just demonstrate with my hand. I showed the sine wave that's coming out of the coil from the magnets rotating within the from the magnets rotating within the coil. And I showed that superimposed on the square wave of power that's going in. And I showed that the sine wave that the generator is producing, that the generator action is producing, is actually a higher voltage to the power that's going in. So its generator motion, at the same time as the input power motion, has a higher voltage. Therefore, the current input drops to 0. And what I'd like to show you on the resistor, the current sensing resistor that I've got hooked up in series, is that every time we have a square wave pulse of power, that is the resultant current peaks. And just have a look at the big ones. The small ones are simply due to the reversing action of the coil every rotation, and that's bleeding through into the sense resistor, just due to the nature of the circuit. So each two peaks, one small and one big, would represent a 360 degree cycle. So what I'm going to do with the scope lead is put it on this coil that's parallel to, there's the first position, half of the coil. So you can see the square wave of voltage and the small current peak at the start of that square wave. So basically what you're looking at is, for that first tiny little blue peak within the yellow square, that's the current acting in the coil and getting the motor back up to speed from the several RPM that it lost since the last firing. So we're only really paying for that tiny blue peak at the start of each voltage cycle, and the rest of that voltage cycle is free. We're not paying anything for it because the generator function is making up for that. And on the other side, that's really the truth of the matter, with it superimposed on the big scope shot. But yeah, essentially it's showing the same thing, just to a more honest scale. But yeah, basically the same thing. So at this RPM, we're using about 2 milliamps at 160 volts, and we'll juice that up a bit. I'll bring it all the way up to 600 and put the limiter on a bit. There we go. I'll whisker over 600 volts, 12 milliamps, and we'll have a look at the RPM there. Just over 2000 RPM. So that's a pretty good median to run this engine at. And what I'll do now is show you those current peaks whilst I load the motor with my hand. So I'm just going to squeeze the shaft. There we go. See the RPM drops a little, and take my hand off and the input current drops down. Squeeze the shaft, there we go, and we can now watch that on the analog meter as well. What I've got is the power supply charging the capacitors, and the meter is between that, so we're going to see a slight buffer delay on the meter. So squeeze away, quite a lot of force there. I'm actually squeezing really hard. It's not going to damage my fingers or anything, but that is getting pretty hot, and it's very uncomfortable because the shaft isn't perfectly smooth. But yeah, that's burning. I don't want to hold that any longer really. Kind of numb, bit of chafing there. And yeah, and that was still at 600 volts, so that jumped up to really over 10 watts. But that's really a lot of power from a very inefficient motor. So the next one will be quite exciting. I'm going to come up with a few more tests to show the nature of how this thing works, and in time I'm going to remove some of the disadvantageous metering effects. I've also ordered a few of these. They are isolated buck converters, so I can replace the 4 transformers. These are basically just it's exactly the same as an isolation transformer. They're only good for 2 watts. And I've also got a new set of transistors, so I might put the whole thing on a board, on a single board, and see just how efficient we can get it. But that will be even more interesting on a high resistance version, because this one here is really just for RPMs. I wanted to play with high RPMs. Yeah, so the next one will be a max efficiency version. Not that this one isn't efficient enough. So check back in soon for a giggle.